This lesson is for Advanced Algebra, lesson 6.4, on the graph of ax squared plus bx plus c. One of the other things you're going to do in this lesson is not just do the graph, but also maneuver between vertex form and standard form. A quick reminder on what vertex form is. Vertex form was the type of equation that we learned yesterday in 6.3. So remember that is y minus k equals a times x minus h. The benefit of that is h comma k is the vertex of the parabola. And the vertex is very important for the parabola because it tells you if it's opening up or opening down. It also tells you, the a value tells you if it's opening up or opening down. But the vertex tells you where you are if you're doing a max or a min. And then it also helps you find the axis of symmetry, which cuts the parabola in half. So this is vertex form of a parabola. Standard form is what we're used to seeing, ax squared plus bx plus c. So if they ask you to go from vertex form into standard form, students need to be comfortable doing that. So as you look at this particular example, any ideas on what we would do first? Looks like we should deal with the power first according to the order of operations. So let's write a quick note here. Typically you're going to do FOIL first. So when I do FOIL on x minus 5, that means we're going to do x minus 5 times itself. So I'm not going to teach FOIL right now. I'm hoping that students are comfortable doing that. So let's just quickly do FOIL here. So the 3 is just going to sit there hanging out waiting for us to finish our FOIL. When I do the first outside insides last, I get x squared minus 5x minus another 5x plus 25. When I add like terms there, I get x squared minus 10x plus 25. And hopefully students are getting good and very fluid at performing that FOIL function. Then we need to distribute the 3 to everything. So I'm going to get 3x cubed minus 30x plus 75. Then finally I need to add the 16 to both sides. That's only going to get combined with the 75. So my final answer now in standard form is 3x squared minus 30x plus 91. So let's talk through those steps again. We started to list them out and then I kind of got hung up in the math here. So FOIL first, then we distribute when the FOIL is finished. So we can say then distribute, and then get y alone. So that's going from vertex form into standard form. The benefit of that would be probably if you needed to graph it or if you wanted to solve using the quadratic formula, which we'll do later on in the chapter. That would be one good method to know how to do. It's getting from one form to another. Some applications of the quadratic functions are the next thing that we're going to talk about. So students should take notes on all of this, and then let's just talk through all the different pieces that we see here. So real life applications of quadratics. Quadratics is one of the more applicable things that we learn in algebra because many objects are being thrown or dropped throughout the world. Those objects are called projectiles. The equation given for the path that a projectile takes is the height of the object over time. So we say h of t. Because gravity is involved, there's a g value involved in the equation, and the g value gets multiplied by a half. The gravity is measured either in feet or meters. Students need to pay attention to which one to grab when they're using these equations. It's a negative because the parabola will be upside down. That's the path that an object takes, is it goes up and then it comes back down. So the a value needs to be a negative. And then the t, or the time, is squared. That's what makes it a quadratic. V sub 0 is called the initial velocity. Initial meaning starting velocity. That gets multiplied by the time. Typically they'll tell you what the initial velocity is or give you some hint for you to be able to figure that number out. And then there's also the starting height or the initial height called h sub o. This equation will usually be provided to you on tests and quizzes, but know, students, that you will have to plug in numbers for g, v sub o, and v sub h, and then calculate further from there. So if you want to look at the equation with the feet and the meters already figured out, Someone plugged in the 3.2 or the 32 or the 9.8 and then they multiplied by a half. So this is typically the two starting numbers that you're going to see. It's either going to be a -16 or a -4.9 next to your t squared. If it's in feet, it'll be a -16. If it's in meters, it'll be a -4.9. And then they'll have to tell you the v sub o or the h sub o. Many times when you're working with this equation, they're going to ask you questions like, when does the object or when does the projectile hit the ground? They also may ask you, how high does the object get? These are questions you should be able to answer very easily based on the things that we've been talking about so far in Chapter 6. To find out how high the object gets, for that you will need the vertex. If you know where the vertex is, and it's an upside down parabola, the y value of the vertex will tell you the height. When does the object hit the ground? If we're talking about an upside down parabola, usually when it hits the ground is where it crosses the x-axis. So for that, we would want to find the x-intercepts. Keep in mind that sometimes the x-intercepts are found on the graph. Sometimes they're found from something called the quadratic formula, which is something that we'll learn and or review later on in the chapter. But keep that in mind, that if you're asked either of these questions, they are things that you should be able to figure out mathematically, not from your opinion. So let's take a look at example 2 from the book. It refers to an object that has this equation as its equation that matches with it. And then they ask us these questions from the homework, questions 8, 9, and 10. How high is the ball after 1.5 seconds? They've also provided a graph that would match with this particular equation. So if we want to find out how high the ball is after 1.5 seconds, notice that the t is the time, which is the x-axis, height is the y or the vertical axis. So if we're looking for a high or a height, we'd want to go to 1.5 on the time axis. So if we go to 1.5 and then read approximately where we are on the graph, wouldn't we say about 50, it's definitely more than halfway, so I'd probably say about 56 feet here. And it doesn't say feet, but I can see in some of the other questions it talks about feet. I'd probably be able to see in example 2 in the book that it talks about feet in the instance there. When does the ball hit the ground? Clearly hits the ground when it crosses the x-axis. So it looks like about right there. It's asking for when, so it's asking for a time. So I'd say t is about, and it looks like it's definitely more than 3.5 seconds. I'd say more like 3.7 maybe. So about 3.7 seconds. And then what is the value of h at that point? Meaning, what is the height when it hits the ground? Obviously it has to be a 0. When you hit the ground, your height is 0. So be careful about how they ask that question. They may say, when does it hit the ground, or what is the height when it hits the ground? The height would be 0, but the time would not be. And then at what times, be careful there, that is a plural, will the ball be 20 feet above the ground? So this is a height, so we need to find where that height is, and then identify the times when it occurs. So here's 20. So it's occurring at what looks like about 3.4 maybe. And then back here, maybe at like 0.3. And these are times, so we want to say seconds on each of these. Now if you said 0.2 or 3.5, I'd probably give them to you. These are estimates, so I'd allow a multitude of answers here as long as they're relatively close. Let's try one more question together, and that's number 12 in the homework. So let's just read it through. Suppose a person throws a ball upward at a velocity of 16 meters per second from the top of a 20-meter building. Write an equation to describe the height of the ball above the ground after t seconds. How high is the ball after 0.75 seconds? Use a graph to estimate the ball's maximum height. After 6 seconds, is the ball above or below ground level? Justify your answer. So right away I see that I'm in meters, so I know that the equation I'll be working with is the h of t, where the a value is going to be -4.9. Then I want to fill in the initial velocity, which they tell me right here is 16. And then the initial height, they tell me it's a 20-meter building, so I'm going to use 20. So that would be my equation down here for part A. How high is the ball after 0.75 seconds? They're giving me a time, so I would actually type in 0.75 for t into this equation, and I would type that in on my calculator. So I went ahead and typed that in on my calculator. I used my negative 4.9 t squared plus 16 times t plus 20 equation. Everywhere I had a t, I plugged in 0.75, and I got about 29.2. And this is in meters, so put an m there. Should have also put like a squiggly equal sign in front of that. Use a graph to estimate the ball's maximum height. So now you're going to type in this equation, being careful to use an x instead of a t. If you use a t, you won't get anything. So make sure you type it in as negative 4.9 x squared plus 16x plus 20. So I've gone ahead and done that. And this was the first graph that I got. So I had a line going this way and a line going that way. So I could tell right away that I needed to modify the window. So when I modified the window, I went to Menu, Window, Window Settings. I knew I needed to see higher up, so I modified that upper number, or the Y max, to be 50. So that was the only number that I changed, and that was just a guess. I probably tried 25 first, and when that didn't look good enough, I upped it to 50. So when I did that, I got this nice graph here. And so now I want to estimate its maximum height, so I want to identify where that vertex is. To do that on a CAS calculator, after you've graphed it and you can see where the point is, choose Menu, Analyze Graph, and then choose, instead of intersection like we've done in the past, choose Maximum. And again, highlight somewhere to the left and somewhere to the right of where the vertex is, and it should identify that vertex for you. And so when you do that, you should get about 1.63 for x or for t, and about 33.1. So then after 6 seconds, is the ball above or below ground level? So from that we can see that from our graph. You can see that the graph is still labeled by ones on the x or the t axis. So 1, 2, 3, 4, 5, 6. So here's where 6 would be. Clearly my parabola is going below ground. So it's below ground at that point, so the height would be a negative number. And so we'd say below ground. The reason is, if I plug in a 6 for t into my equation, I get a negative result. And I can also see that from the graph as well.